Hi everyone, welcome back to my channel MLearners. So the topic for today is what is data in data science. So let's focus on this topic, and apart from that we will also see what are different types of data and how data is collected. Okay. So let's start with what is data in data science. So before that, everything in AI and data science revolves around one thing, which is data. It is like a oxygen for these fields. Okay, so without data, which is very basic and a building block for any data science project to start, so we have to understand what exactly is the data. Okay, any piece of unprocessed information such as numbers, text, images, from where meaningful insights can be obtained is called data. So what they are saying is any piece of information like numbers, text, images, or it can be audio files or video, any piece of information from where a meaningful insight can be obtained is called data. So anything that can be recorded, stored, or analyzed is considered as data. Okay, based on the storage itself, there are different types of or different categories of data. Okay, we'll see that in the further video. So speaking about data is itself a data. So right now we are talking about data, and I'm recording this video for YouTube, so that itself becomes data. Okay, that's a fun fact actually. Anyway, so there is a difference between data and information. So let's see the differences. So data and information. So data is raw, unprocessed fact. There is no meaning on itself. For example, 30 degrees Celsius, 32 degrees Celsius, 35 degrees Celsius. So when we are talking or observing or noting these values, yes, we are understanding, okay, there is this temperature, but if you want to make meaningful insight out of it, right, then we should process that and form some meaningful insight to it. So that becomes information. So information is processed. So there can be different processing techniques based on different types of data. So if you apply some processing and making that readable, that becomes information. So information is processed data with meaning. So based on this, if you want to make an insight, so we can say that, let's say this is everyday collected temperature. So first day, this becomes second day, and so on. So if we see, the temperature is keep on getting increased. So it is getting hotter each and every day. So that is what the insight we are getting from the raw data. So that becomes an information. So this is the information. So data is a raw and information is more meaningful, right? So that is the main difference between data and information. So why it matters in data science? So why we need to understand data and information and their differences. So data science start with data collection. Okay, so the first process is data collection, and then we apply a lot of processing techniques on it, like cleaning, different processing techniques, and further we can do analysis like EDA. We'll discuss EDA in the future. So all these are done on data on top of raw data. So the final goal is to convert that raw data into meaningful information. Okay, so that is why the reason we need to understand what is data and what is information. Okay, so one more thing is, right now we only have 3 days temperatures, right? So what if you have one sec, you have 100 days, or let's say 1000 days temperatures. So you can't see the data. That means you can't go to every data one by one, just like how we went like first day, second day, third day. Since we only have 3 observations, we just directly said, okay, it is getting hotter each and every day, right? But this is very real world. We will analyze thousands of records, right? So in that case, you can't just open an Excel file or wherever that is recorded. You can just open that and just try to get an insight of it. You have to do certain processing, certain systematic approach to get a meaningful information out of it. So that's where this process will come into picture. Okay, so when data set, so usually this is called a data set. Whenever you have more than one piece of information, and when you have more than one record, the first record, second record, and so on, n records. So when you have this kind of information and with multiple columns, right? So first column, second column, third column, and so on until nth column. Okay, so this becomes a data set. So data set is what input for any machine learning algorithm. Okay, so that is a processed data set. Okay, not a raw data set. You have to process it and then send it to a machine learning algorithm. Okay, I hope you understood the meaning of what is data and information and what is a data set. Okay, moving on. There is one more important term which you have to understand. What is metadata? Okay, metadata is a description about actual data. Okay, we'll see what is with an example. So if your data is a book, metadata is the information on the cover, like title, author, and publication. So when you take a book, so if it has certain details about the author, the title, what is book all about, so this information becomes a metadata for that book. So metadata is description about actual data. And we can take one more example of this image. So this is an image. So this is the actual data, and what will be a metadata of this image is the file name, the author who created that image, and the date and the location. So all this becomes the metadata for the actual data, which is an image. So that is a metadata. So moving on, so we'll see what are types of data, which is very important. Okay, in real world data science, data is not always clean and organized. Based on how it is stored and structured, data is divided into 3 main types. Okay, data. So for now we have seen what is data. So moving on, what are different types of data? We'll see there are 3 main different types of data. So starting with the first one, structured data. So the name itself suggests that structured data means it is organized and can be stored in a structured format. So what is a structured format? As we already saw, a data set, which is a tabular format, right? So this is first record, only one record. So ID, name, age, salary. So when you can represent something in rows and columns, that becomes a structured data set. So here we have one row and how many columns? Cross 4 columns. So this becomes 1 cross 4 data set. Okay, so data set is 1 cross 4. So how data set can be stored? So if you ask me, if the data based on the use case and the size of the data, the storage of the data or structured data varies. Okay, so typically if you have lots of data, so that needs to be stored somewhere, right? So they store in something called as database. Okay, so these are SQL database. Okay, where you can use SQL language to query and get do all the CRUD operations. Okay, you can do all CRUD operations. Okay, so they are stored in typically like MySQL, Postgres, etc. Okay, so if you want to store that in local, you can use spreadsheets or Excels. Okay, but these are typically of less size, because whenever the data exceeds certain amount, like in GBs, it's better to always to store the data in databases, because that is more efficient. Okay, whereas spreadsheets, they are not that efficient, correct? So that's about structured data. So moving on to semi-structured data set or semi-structured data. So semi-structured data is partially organized. That means some part of it is structured and some part of it is unstructured. Okay, so it has a flexibility to alter the schema. Okay, I'll explain by giving an example. So here we have one example of a semi-structured data. So semi-structured data is a dictionary format, is in a dictionary format or JSON format. Okay, wherein tomorrow if you have some new field, now we have three fields: name, age and skills, right? Tomorrow if new observation or new record comes in and that record has, let's say, experience as a new field and a salary as a new field, so these fields can easily be added to existing schema so that the other fields may not be getting altered here, whereas in structured data set these fields are fixed. That means if at all there is a new field comes into picture, the whole data set will have to adapt to that new fields or new columns. But here you may not have that issue, because the format is in such a way that it is flexible to adapting for new changes into the schema. Okay, that is a flexible schema. Okay, it is flexible. So that is semi-structured. So you can store this semi-structured data into JSON file. So there is a file called .json, just like Excel file, XLSX. So similar to that, so we have JSON file and XML file. So all these are examples of semi-structured. So even email. So email has some structured, right? Some structured data, which is subject, okay, CC, and the sender, right? So all these fields are structured, but the content what you are typing in, like if you add some attachments or if you type a text, so this itself is unstructured. So it is altogether an email is an example of semi-structured data. Okay, so it has schema, but it is not fixed. Okay, moving on to unstructured data. So unstructured data is unorganized and raw. Okay, so that means it doesn't have any properties of tabular format. You can't store a photo, an example, or a video or an audio into a tabular format, right? You can't store in a tabular format. Okay, so it means it doesn't have any fixed schema and it can't be stored in a fixed format. Okay, that is about unstructured data. And the examples of unstructured data, as I already said, photos, videos, audios, and even the text file or text comes under unstructured data. So most data on internet, when I say most, 90% of data in internet is unstructured. So that is why the reason you are right now seeing the boom of LLMs. Okay, so LLMs are trained on unstructured data. So for the most part, the input for LLMs like ChatGPT, okay, all the inputs for this is a video or an audio. So all this is an input to the LLMs. So because the data where it is taking is from internet, and internet contains 90% of unstructured data. Okay, moving on. So it's very important to understand how data is collected. Okay, so before that, data collection is the process of gathering information from different sources for analysis purposes, okay, or building a predictive model. Okay, it can be done for multiple purposes, right? Data collection is a process of gathering information. So depending on use cases, the data collection process varies. So depending on what problem we are solving, the collection process itself varies. Okay, so important terms to understand: raw data versus processed data. So when you have decided that you're working on particular use case, you started collecting data from internet. So that in internet, the data can be a raw data or a processed data. So when I say raw data, it is unfiltered. It can be a lot of junk, or it can contain a lot of unusual properties which you don't want. So you can clean that data further. So the data, most of the data in internet is raw data. Okay, so when we have clean information that you can directly use it for your analysis purposes, that is a processed data. Okay, that is a difference between raw and processed data. So, and moving on to population and sample. So population, when you have again a problem at hand, so you are in a stage to decide whether you have to collect all the information available, or you want to just analyze on sample of information. When I say all, so let's say this is a circle belongs to a global information, global data, and if you want to consider all the data inside this globe, then that becomes a population. Or if you want to only operate on certain portion of data, this becomes a sample. Okay, again you can't use all the information available. So the data you're taking is considerably enough, whether you want a sample of data or all the data to train particular model, right? So these are the important terms. Moving on, data can come from variety of sources, as we have already seen, each with its own advantages and use cases. Here are the key types of data sources. So there are different sources or different ways of collecting data. So one is primary and secondary. So when I say primary, this data is collected by you. That means you're doing surveys, or you're doing certain experiments and observations and collecting the data by yourself, and by taking certain interviews. So that means the main difference between primary and secondary is that the data is not with you, and you are about to collect, and you are the one who are collecting the data. And this data most probably will be very clean and useful to you. That means you are deciding what are the fields you are collecting so that you can analyze further. So that means you have a control on the collection process, whereas secondary you don't have any control. So control is not there. Okay, that means you are relying on already available data set. Okay, so that means existing data sets, government records, research papers, public data sets, all this comes under secondary data, which is already there in the internet, or already there somewhere, already stored somewhere. So that means you're relying on others data to use it for your use case. Again, that comes with various advantages, disadvantages. That means if we talk about advantages, the collection process, we are totally skipping that collection process, right? You are just downloading it from somewhere by using an API. Okay, you are using an API to collect the data. Just like, for example, you are using if you want to collect the information about weather, you're using weather API. Or if you want to use stock data, you're using Yahoo Finance, the open source, which is open source one. So you're using open source APIs to collect the data, get the data directly, right? Or else there is this Kaggle, you're getting the public open source data sets, public data sets. Okay, or else you're using archives from research domain to get the data. So all this comes under secondary data. Okay. And there is one more thing which is emerging right now, which is synthetic data collection. So emerging way of generating our own data. Okay, so how we are doing that? You're doing that using LLMs. So right now people are using LLMs to generate their own data sets, like images. They're creating their own images, or else they're creating their own unstructured data set, which is, as we already saw, tables and columns based on their use cases, or tabular data based on their query. So all this comes under synthetic data collection, okay, using LLMs. I think I have covered most of the part here, and I hope you understood what are the topics we have discussed about the basic building block of any data science project, which is data. How is data collected, and difference between data and information, what are different types of data. I hope you understood all these things. If you have any doubts, you can comment down. For now, take care and bye.